everyone. So I've been running some experiments around a question that keeps coming up as we build out multi-agent system. How do we track who delegated what to whom across service boundaries and trust domain? Tools like MLflow and Phoenix do a great job at the application level tracing what happens inside an agent. But once you have agents calling other agents, a third party API across trust boundaries, there's a gap in visibility around delegation chain itself. Who initiated this? Was this agent supposed to call that resource? So I built a working prototype which runs locally in a client cluster and uses Envoy, sidecars, and OpenTelemetry to capture delegation provenance at the infrastructure layer with the zero agent, like I'm not instrumenting any agents. I want to walk you through the approach, show you what it captures, and then do a quick demo. So, as I said, we have great tooling today for understanding what happens inside agents that give us execution traces, token counts, prompt level visibility, but that's application level view. What I have been experimenting with is a complementary layer. What happens between agents? When you have multi-agent system at scale, especially across trust boundaries, the question shifts from what did this agent do to who asked it to do that, and should that have been allowed? We require principal attribution, cross-boundary delegation tracking, behavioral anomaly detection, and an audit trail that's independent of the agent themselves. These aren't things application level tracing is designed to answer. They are just a different observation point. So the core idea is simple. Every request through the system produces a delegation chain from principal to agent to agent to resource. We call this a trust DAG. The first thing it gives us is full provenance per request, not which model ran, but who is accountable, which human or service kicked off this chain, which agents acted on their behalf, and what resources were ultimately accessed. Second, the observation happens at the infrastructure layer. I use Envoy sidecars that emit span for inter-service calls. Trust metadata like principal, caller, target, hop kinds gets propagated as headers and tagged onto spans. So the agent are not instrumented, they don't even know they are being traced. And thirdly, because we have the full DAG for every run, we can compare it against historical baselines. We detect novel edges, an agent calling a service it's never, for example, an agent calling a service it's never called before, novel delegation paths, fan-out spikes, retries, capability alignment violation when an agent's observed behavior does not match its declared permission. All of that gets scored into an automated risk assessment. So for this POC, I'm just using historical baseline, but the idea is we can have these evaluations of trust done based on various parameters, using OPA filters, also using agent evals, like how not just how good an agent is, but also can we trust, or what is the risk of taking the path that the agent is taking. So let me highlight 4 properties that are specifically relevant for our security concern. The first is cross-boundary visibility. This works across this capture delegation hops across heterogeneous agent system, different teams, frameworks, runtimes. For third party and external API, the egress sidecar captures the outbound edges, which agent called what on whose behalf. But cross-domain federation is possible if both party decides to participate. Tamper-resistant audit trail. The spans are emitted by the Envoy sidecar, not the agent themselves, so a compromised agent cannot alter its own trace data. And the observation point is outside the agent's trust boundary. For compliance and security review, this is a meaningful property. Policy enforcement. So this is where it gets interesting for future, because observation happens at the proxy layer we can evolve from passive tracing to active enforcement. The same sidecar that observed delegation could enforce capability policies, rejecting calls that violate declared permission before they reach the target. And another thing that I want to highlight is it's not just important to reject these violations, but also to keep an account of that. For example, in occurrence, how things work right now, if an agent has an access to a database that has a table called employees and a table with all the secrets, and this agent is never supposed to call the secret table, so it does not has the authorization to do that. And even if it does, that is blocked or that is denied. But just denying is not enough. So we need to, when agents are running at scale, we need to highlight or find these anomalous behavior that the agent has done, and we need to kind of like analyze what triggered that, what delegation caused that. So, and just I know like these calls would be rejected, but just rejecting is not enough. We also need to have capture what caused it so that we can prevent it next time. And for this POC, the agents are not instrumented, but if they are, it's nice. It will be we can inject more context to it. But for this, we are just using W3C trace context so that it aligns with OTel native propagation standard. So these properties are complementary to agent application level tracing, and together with application level tracing, we can cover the full stack from LLM internals to inter-service. So let me show you the live demo and what is my setup. We have a kind cluster running 4 agents with Envoy sidecars and an OTel collector. This is the rudimentary dashboard that I created. So I have 3 agents, chat agent, read agent, and sales agent. Here is their dependencies. The chat agent can access read agent, summary agent, and sales agent, and it has the capability to route prompts, aggregate result, and it can do multi-agent orchestration. We have read agent. The capability is just to read employee and list employee, and it can only access the mock database. And the sales agent has capability to get only sales and employee sale, and it has also access to mock database. And the summary agent it summarizes all the results that get pulled from read and sales agent, and it can access only read agent. So, and here are the users who have already accessed the system. There is no identity implemented yet. So, and this is the agent this is the system that is running. We have 5 agents, and our connected resource is database, and we have the gateway. So let's go, and let's say that I am Alice, who is an existing user. As you can see, Alice has made many requests already. So I will start with Alice, and I will So Alice sends this request, and you can see that Alice got all the employees, and we get the run ID for this. So now I will go in the trust tag. So we can see that this is the delegation path. User Alice made a call to chat agent, and this is it uses a principal to agent hop, and we have some other metadata. So the chat agent made a call to read agent, and we can see that this is an agent to agent hop, and it was invoked just one. And if you can see the assessment, the risk score is 0 because it has appeared in prior runs. So it says no anomaly detected, this matches baseline behavior, and the capabilities of both the agents are aligned. So now we have the mock database, and we can see the assessment is, this is the delegation path. So Alice called chat agent, which called read agent, and read agent called the mock database. And we don't get, this is the direct accessor who accesses this database directly. So only read agent accesses this database directly, and the delegation chain is over here. The read agent was called by the chat agent, which was called by Alice. And if you go in the assessment, so as I said, there are no anomalies found, and this matches the baseline behavior. So what would happen if, let's say that I'm using a user that is not accessed the system before? Ideally, in a normal scenario, that will never happen because the user will not have the credential to access the system. But the idea I'm trying to show over here is what happens when there is a some novelty is happening in the system, or something that the system has never seen before, because how the system generates trust is based on historical baseline. So let's go again. Now, by the way, if you come over here, you can see we can also see that this has been come up here in the, yeah. Anyways, so now let's change this to let's say a threat user. This user is now in the system. I cannot spell threat. So let's copy this run ID and see what went on over here. So we see that this is a threat user, and it highlighted this is a novel edge. This user has never accessed the chat system, and the assessment, it gives 25 because it highlighted they are novel paths. This path has never been invoked before, and this path has also never been invoked before. But it's still, the agents are aligned, they are doing what they are expected to do. Now again, the same thing, this so it accessed the mock database, and if we see what was the explanation, so it says that this database was accessed because this user triggered this request, and the direct accessor was the sales agent. Out of chat agent and sales agent accessed the database, and this is the delegation chain. And if we go to the assessment, we see that there's a risk score of 25 because there were 2 novel edges, and both these in the principal was never seen before, but the agents are still aligned. So that's the working prototype. To recap, full delegation provenance, principal to agent to resource, are captured entirely at the infrastructure layer. No agent code is instrumented. For next steps, I think there are 3 things worth exploring. First, combining this delegation layer with the agent level metric works, inputs, outputs, token counts, so we get both who asked whom and what was said from the same sidecar and collector pipeline. Second, getting this running in KAgenty against real agents to see where it breaks. And third, looking at how the same observation layer could move from passive tracing to active policy enforcement at the proxy level. And happy to pair with anyone who wants to dig into any of this. Thanks again for watching.